Hey guys, welcome back to another Math and Physics Resource Center video. My name is Brendan, I'm going to be your tutor, and today we're going to go over the ratio test and how we can use it to test for convergence or divergence of a series. Alright, let's get into it. Alright, let's get into the ratio test. So we're going to start out with the series going from n is equal to k to infinity, where k is just a constant, of a of n, so this is just going to be another function of n. And what we're going to do for the ratio test is we're going to take the limit as n approaches infinity of the absolute value of a of n plus 1 divided by a of n. And then if we want this to equal some constant L. So, and then our three criteria are if L is greater than 1, so after we simplify all of this and we take the limit, if L is greater than 1, the series is going to diverge. If L is less than 1, the series is going to be convergent, and it's actually going to be absolutely convergent, which is one really nice part of the ratio test. And then the last one is if L is equal to 1. This tells us that the ratio test is inconclusive and we have to try doing a different series test with it. Alright, and so let's go ahead and jump into this example here. So I have the series from n is equal to 1 to infinity of 7 to the n over 3 to the n plus 1 times n plus 1. Okay, so let's just go ahead and take a look at our form here. So let me go ahead and write out each term. So here is our a of n, and then let's go ahead and write out the a of n plus 1 term. So then we can just plug everything into our limit. So this set n plus 1, so anywhere we see an n, we're just going to plug in n plus 1. So this is going to be 7 to the n plus 1 divided by 3 to the n plus 1 plus 1, and then n plus 1 plus 1. Okay, and so then this is going to be equal to 7 to the n plus 1 over 3 to the n plus 2 times n plus 2. Okay, so now let's go ahead and plug everything into our limit. So we're going to take the limit as n approaches infinity of the absolute value of a of n plus 1, so that's this term down here. So that's going to be 7n plus 1 over 3n plus 2 times n plus 2. And then we're going to divide that by a of n. So that's going to be our 7 to the n over 3 to the n plus 1 and times n plus 1. Okay, and so we want to simplify this double fraction, and what we can do is we can keep the top, switch the sign from division to multiplication, and then flip the denominator. So this is going to be the limit as n approaches infinity of 7 to the n plus 1 divided by 3n plus 2 n plus 2. And then, gotta get rid of the absolute value. Gotta put the other piece in first. Okay. So now for the denominator, we're going to multiply by the reciprocal of the denominator. So that's going to be 3n plus 1 times n plus 1 divided by 7 to the n. Alright, now we can put the absolute value in. Okay, so now we want to simplify this piece here, and we want to simplify any pieces that we can. So I'm actually going to rewrite some of these exponents. So this 7 to the n plus 1, we can rewrite that as 7 times 7 to the n. So it's going to be the limit as n approaches infinity of, so our top we can go 7 times 7 to the n. And the reason we can do that is because when we're multiplying these bases, we add their exponents. So this has an exponent of 1, so it's just going to be, when we add the exponents, it would be 7 to the n plus 1. So we end up with the same thing. And so we're going to do the same thing here. So it's going to be 3 squared times 3 to the n times n plus 2 multiplied by, so the same thing on this one, it's going to be 3 times 3 to the n times n plus 1 divided by 7 to the n. Okay, so now what we want to do is let's simplify. So I have a 7 to the n I can cancel out here, 7 to the n. A 3 to the n I can cancel out. I have this 3 is going to cancel with one of the 3's that's in my exponent. And let's see what we're left with. So we're going to have the limit as n approaches infinity. Looks like I have a 7 times n plus 1 in the numerator. And in the denominator, it looks like I have a 3 times n plus 2. Okay, we're going to go up here. So let's go ahead and finish simplifying this, and then we'll evaluate the limit. So this is going to be the limit as n approaches infinity of, let's see, 7n plus 7 divided by 3n plus 6. Okay, so what I'm going to do is I'm going to multiply by 1 over n to both the top and bottom. So it's going to be the limit as n approaches infinity of the absolute value of, looks like we're going to get 7 plus 7 over n over 3 plus 6 over n. Okay, so now we can evaluate our limit, and so just like on previous videos that we've had where the infinities in the denominator for these terms, this is going to go to 0, this is going to go to 0. So it looks like our limit's going to end up being equal to 7 over 3. Okay, and so now let's go back up to our options we have, right? So if L is greater than 1, then the series is going to diverge. So here we got L is equal to 7 over 3. That's greater than 1. So that automatically tells us that our series is going to diverge. Okay, so yeah, this is just one example of using the ratio test. So in the next video, we'll get into an example where we find that the series is going to converge. All right, thank you for watching.